magnetic tapes. Okay, magnetic tapes is also a recording mechanism, okay, to store the data. So what will happen in magnetic tape? Magnetic tape is when it is magnetized, we'll treat it as a 1. When it is demagnetized location, it will treat it as a 0. Okay, and magnetic tapes are sequential devices like serial ESEs. Okay, magnetic for sequential devices. Okay, these are stored at zeros and ones. Okay, these can be used to store large amount of data. Okay, because these are cheapest for cost per bit. And magnetic tapes are depending upon the speed rate, read rate. These are classified depending on the read rate, how much fast we can read it. Okay, and density for inch area, how many bits are there, read rate and density. Density is nothing but number of bits per inch. Okay, read rate means how much fast the tape is rotating. So magnetic tape is similar to the cassettes which we have seen in the earlier days. Okay, there are cassettes used to rotate. Okay, like cassette format, like this. There is a reel. Okay, there is a read rate head here, so like this it is rotating through some mechanism. Okay, the magnetic cassettes actually. So some read rate head will be there, it will read it. Okay, so this is magnetic tape actually. So it is cheapest and cost per bit is very less, and it is used to store as the backup data, because in hard disk nowadays hard disks are there. So again, to backup the hard disk data, magnetic tapes are used. Okay, to archive data. Okay, it used to store large amounts of data. So one disadvantage with magnetic tapes is that when it is stretches, this tape, and the tape stretches, the data will be lost actually. Okay, and one more thing is that it is even though it is cheaper, we cannot edit the file in run, because this is sequentially record. For example, we cannot update the files immediately because we have to go that particular, since it is a sequential reading, we cannot update or insert and delete the files as when we need it. Okay, and entire data can be erased at the same time, entire data can be written at the same time. Okay, and I already told you, if it stretches, data will be lost. Okay, so we have to protect it, but these are lightweight actually. Okay, used to store huge amounts of data. This is the introduction of the magnetic tapes. See the magnetic tape physical organization. Okay, it is a magnetic material. Okay, in that actually the frame magnetic tape is divided into horizontal and vertical lines. Okay, horizontal lines are nothing but tracks. Okay, horizontal division is tracks, and vertical division is called frames. Okay, and each frame stores 8 bits. Okay, that means each frame contains one byte of data. Okay, 1 byte of data plus 1 parity bit to check the parity code. That means each frame, each byte is, again, it counts the number of, while writing the data, it counts the number of ones, that is even parity or odd parity. If the number of ones are even, then it is called even parity. It is indicated by 1 if the number of ones are even. For example, number of bits in the byte, number of ones are, for example, 4, then it is even parity and it is indicated by 1. Okay, if the number of ones are odd, then it is called odd parity. Okay, odd parity will be indicated by 0. So while reading and writing, it will check the parity. Okay, so that error correction can be done. Okay, again, tracks are called, horizontal lines are called tracks. There are 9 tracks totally. Okay, vertical ones are called frames. Okay, so each frame by frame it will read and write. Okay, now actually the magnet frame data is stored by, actually for each magnet frame, starting is called EOT, BOT, beginning of the tape. Okay, it is indicated by some silver mark. So beginning of the frame, some silver mark. So similarly there is an end of the tape, EOT. Okay, so that beginning of the take where the BOT, when BOT means it is there is a photovoltaic photo sensing device is there, it will sense that is the beginning of the tape, and EOT is there end of the tape, that will sense it will be the end of the tape. Okay, these tracks actually data is recorded in the form of blocks. Actually blocks are nothing but records. Okay, I mean that means multiple frames are called record. Okay, there is a gap between each record. For example, records are there, records, blocks. Okay, so there is always a gap between intra blocks. For example, take like this is one record. Okay, this is one record. So again there is a small gap, then it is again one more record. So the gap is called IRG. This is one record, this is another record. Okay, you understood? The gap between records is called intra record gap. Okay, so there is set of records is called block. Okay, then for example take this. Record 1, record 2, record 3. Okay, you understand? R1, record 1, there is intra record gap, R2, intra record gap, R3. Okay, these are set of records. These set of records are called block. Okay, there is a gap between blocks also, that is intra block gap. Again records will start. R4, R5 like that. Okay, this is again intra block. So this is called intra block gap, IBG, intra block gap. Okay, there is intra record gap and intra block gap. Okay, and there is a beginning of the tape and end of the tape. Okay, so this is about the magnetic tapes organization. So the supply, like cassette, it is there is a supply reel where the magnetic tape will be supplied while rotating, and there is a supply reel. Okay, which supplies the magnetic tape. There is a take up wheel. Okay, this magnet tape will be taken. There is a read write head. This is rough diagram. There is a read write head. Okay, which will read. Okay, this will rotate, these two will rotate. Okay, this is supply reel, this is take up reel. Okay, this will both will rotate, and this is the read write head. It is sequential reads. Okay, this is the organization of the magnetic tapes. So magnetic tapes advantage is that it stores the bulk amount of data. It's used as a backup archive data, but it is slow and it will be affected by dust also, and it stretches, data will also be lost. Okay, so and data also cannot be accessed randomly. It is in sequential arrays. Sequential access can be done. Okay, I mean since this is a sequential device, serial, like we can access one bit after another, so we cannot update files intermediately. Okay, so these are the, but only advantage is cost per bit is cheap and we can store large amount of data. Okay, so these are used as a backup for hard disk mechanism or archives for the data, huge volumes of data. Okay, thank you. We learned about magnetic disks and semiconductor disk for the memory storage. Okay, now there is another way of storing the data is optical disk. Okay, in optical disk what will use? We'll use laser light. Okay, laser light. Okay, okay, so optical, this is optical data reading. So here there is a plastic, circular plastic base is there, plastic base, circular plastic base there. Okay, in that there is a material, this is a plastic plate upon which there is a material where the data can be stored. Okay, plastic disk, upon which a material to store data. This material stores zeros and ones. Okay, materials where the data, where there is a material which can be programmed to zeros and ones. How it can be programmed? It can be programmed in such a way that reflectiveness. Okay, high reflectiveness or low reflectiveness. Okay, one means highly reflective. The material is programmed in such a way that highly reflective to the laser light. That is called one, and low reflective. Okay, high reflective, low reflective. Okay, the material is programmed in such a way that high reflective and low reflective. So when laser light is focused on that particular location, if it is reflecting high, it is called 1. If it is reflecting low, it is called 0. Okay, so plastic disc upon which the material where the data can be stored, and above which there is a thin layer of metal. Thin layer of metal. The metal is made up of aluminum or gold or silver. Okay, so this is the way of CD drives. You know that compact disc, those are very popular actually. Okay, CD is nothing but compact disc. Okay, so what is the diameter of the disc? It will be around 12 centimeters. And how much data it can store? You know that 700 MB. Okay, this is about basic about CD. Okay, there is a laser light upon while falling, after falling it on the material. If it is reflecting high, then it will be read as 0. If it is reflecting low, it is read as. So now we'll see that internal construction of the CD. Okay, CD, we have studied about magnetic disc. This is similar to magnetic disc, but there is a small difference. What is that? In magnetic disc is made out of concentric circles. Okay, like this. So these circles are called tracks in magnetic disc. Okay, and each track is divided into sectors. Okay, this is the magnetic disc. So there is a read write arm goes with which on the particular track, that means particular circle. After that, that goes to the particular sector. Okay, but in CD, how it is designed? CD is a spiral type design. So that means data will be stored in the form of spiral. Okay, this way the data is stored in CD. This is CD, optical disc. Okay, the data is stored in the CD. So these concentric layers, this is spiral type. Okay, this spiral type is divided into sectors of equal bytes. So each sector stores equal data. Sectors of one sector, this is. Okay, sectors of equal bytes. Okay, so this disc rotates. When it is at outer edge, it rotates slowly, because there are many sectors at these sectors are distributed equally. Okay, equal means equal density. Outer edge. So when it is at outer edge, it rotates slowly, because it in outer edge there are more sectors. Okay, outer edge, slowly rotation. When it is inner edge, it rotates fast. Inner edge, fast rotation. Okay, and the data can be accessed here randomly also, but most of the times it is sequential data. Okay, sometimes we can access randomly also, because we can go to the particular sector also. Okay, but it is a sequential data device. Okay, outer edge it is slow, inner edge it is fast, and because it is in spiral type, the density of the data stored can be higher than the magnetic disk. Density is high because in tracks actually there is a little gap between the tracks actually, but it is spiral type, so the density will be more. Density of data will be density of data more. Okay, but access time of the data when compared to magnetic disk, CD is slower. Access time, why it is slower? I'll tell you. Access time slow, that means optical disc is slower than the magnetic disc, around 10 to 40 milliseconds. Why it is slow? Because it is spiral type. But here there is a particular track we can directly go, because it is arranged in concentric. We can directly go to that particular sector track, and after that we can go to the sector. But it is spiral type, it will take longer time to read and write the data. Okay, this is magnetic discs. This is about the introduction about the CDs, actual optical disc. Learn about the reading mechanism of the optical disc. Okay, what will happen? Optical disc, take this is one track, actually track of one sector. Okay, so the optical disc is rotating. So in the optical disc the data is stored in the spiral form. Okay, like this. Okay, spiral form. Okay, what will happen? Take this some small portion here, some sector or some small portion here. So when the optical disc is rotating, okay, what will happen? So in optical disc, this is optical disc spinning, this is turning. Okay, so take this optical, these are called pits, actually this is called land. Okay, land is highly reflective. Pit is less reflective. Okay, so how the lands and pits are formed, we'll see that. Okay, so what will happen for writing to the CD? What will you will use it? High intensity laser. For writing into the disk, for writing data into the disk, we'll use high intensity laser. Okay, because high intensity laser is required to burn the disk. Actually burning is nothing but there is, I'll tell you, high intensity laser. Okay, so writing into CD is also called burning. Burning means because they will continuously turn on and turn off the laser. Okay, so for example, if it is required 0, they will turn on. If it is required 1, they will turn off. Because when you turn on, there is a organic material will be there, dye will be there. Okay, this is plastic, above it some organic material will be there. So when you high intensity laser is turned on, it will decompose the material here. Okay, decompose the material and deform it, it will form as a pit. Okay, so when it is want to write 0, it will turn off, that will call land. It is purely highly reflective. Okay, you understand, the material, organic material or the material which data is stored is decomposed by the, deteriorated or decomposed by the high intensity laser, which forms the pit, and it acts as a less reflective. Okay, and remaining is the normal, because if you take the empty CD with the fresh CD without writing the data, it is highly reflective, because completely all are lands. Okay, after writing means you are creating the pits. Okay, that means some areas are less reflective. Okay, this is the way by high intensity laser is used. For reading the data from the CD, we use the low intensity laser. Okay, just to read this reflective pits and lands. Okay, this is the way we use the read the data and write the data to the laser disc, the optical disc. Okay, now end of CD is DVD. DVD is digital versatile disc. Digital versatile disc. Okay, DVD. So in order to understand, actually you know that DVD stores more data, because CD can store data up to only 700 MB. Okay, whereas DVD can store data up to 8.5 GB. So how it is increasing the data is possible. Okay, I have to say that because both are stored in the data in the spiral form only. Okay, so how the DVD is storing more data? Because see that first thing is that the density, the width of the track, this is a track, the width of the track, okay, in DVD is less because tracks are closer. Okay, that means in DVD track width, for example CD, the track width is 1.6 micrometer width. Okay, so track width is 1.6 micrometer, whereas in DVD track width is very less, it reduces to 0.74 micrometer. See that each track width almost off. Okay, track width is reduced. After that, pit length. So in each track, for example take this track is there, so data is stored in the form of pits and lands. Okay, so pit length is reduced from here. In CD the pit length is more. This is pit length. For example take this is the pit length, this is the pit length, for example take it. So here the pit length is 0.83 0.8384 micrometer. Okay, bit length is nothing but one bit is used to store roughly one bit. Okay, bit length, whereas here the bit length is reduced. That means for the same area it is stored, it is 0.4. Okay, 0.4 micrometer. Okay, so when the bit length is reduced, that means the area which is used to store the data is reduced and the distance between tracks is also reduced. So the laser is also to be stronger means more wavelength should be reduced so that it can read small areas. Okay, so wavelength of the data, here the wavelength is around 850. Okay, because it is using somewhat bigger area, so bigger area it means wavelength can be bigger laser. Here the wavelength is reduced around to 630 to 650 nanometer, so that the laser can read smaller pictures. Okay, this is the way the density of the DVD is increased. One more way is that here in CD there is only single layer of data. Here in DVD there is two layers of data storage. That is how it is. We'll see that two layers. Here single layer. That means here two layers. What does it? We'll see that. Okay, two layer. How it does it mean? Single layer means there is only, for example, data is stored like this. For example, this is the plastic material. Okay, plastic upon which the material which we have to use the bond. So the data is stored like this. Okay, bits and bonds. Okay, this is called single layer. Okay, single layer. But in DVD there are two layers. One is that this is the opaque, that is non-reflective, opaque material. That means it doesn't reflect, whatever it means. Okay, opaque and doesn't allow the light to pass. This is plastic. Okay, after which there is one layer of data. This is one layer. Okay, again there is a translucent. That means translucent material means that is partially reflective. It doesn't completely stop or doesn't completely allow, partially reflective. Okay, upon which again one more layer. Okay, this is the way that DVD. See here in DVD there are two layers. Okay, one layer. So how does we can distinguish and we can read that these two layers? We changing the intensity of the laser. Okay, we'll read it using different intensities of the laser, so that these can be read. One type of laser can read this type, one different type of laser. One type of laser can read second layer. One type of laser will read the first layer. Okay, by changing the intensity of laser we can read the two layers. Okay, that's why the density is more in DVD. Okay, around 8.5 GB. Okay, you understand now. This is two layer. This is single layer in CD. This is two layer. Okay, this is the way DVD works. There is one more thing is that DVD also on one Blu-ray disc actually. So Blu-ray disc is used to store more capacity than the DVD. Okay, more capacity than the DVD. So the difference between Blu-ray and, because it has the more capacity, it can store high definition movies actually. So big movies, games and everything we can store it. So it is developed by the BDA Association. BDA means Blu-ray Development Association. That means this is a set of companies. Okay, and they developed this Blu-ray. Apple, Panasonic, Samsung, Sony, like that. Okay, set of Blu-ray Association. So here how we are improving the density when compared to DVD. So in DVD we are using around 650 nanometer wavelength laser light to read the data. Okay, that means in Blu-ray we use lesser wavelength, 405 nanometers. That means that is more sharp. It can read, wavelength is less. Okay, wavelength is less in Blu-ray, so that it can read more data. That means density of data by using small, it can read small area. Okay, so the density will be increased by 10 times. Okay, even a single layer DVD can store up to 4.5 GB, for example, single layer. Okay, whereas Blu-ray single layer can store up to 7.8 GB. Okay, and the layers in DVD up to we can go up to 2 layers. Okay, in one side we can do up to 2 layers. In Blu-ray nowadays we can go up to 12 layers. 12 layers means, you know that layer means this is mastic material, this is first layer of data storage, again second layer, okay, third layer, like this. Up to 12 layers we can store in Blu-ray. Okay, you understand, 12 layers, so the density will be more. So there are in Blu-rays up to 50 GB discs are also available. Okay, and the advantage of optical disc is that there is the lifespan. See, optical disc they can store the data up to 20 years. Okay, and it doesn't affected by the external fields also. Okay, external magnetic field and everything, once it is stored it can be stored. Okay, these are used to store a lot of files. Okay,